Hello students, welcome to the course on Basic Electronics Engineering and the course code is EC101. This is the code for BTech first semester CSE, IT and FT students and second semester ECE students. Myself, Dr. Surojit Bosak, Assistant Professor of ECE Department, Guru Nanak Institute of Technology, Kolkata. And this is my official email address. Today we are going to discuss about lecture number 2 from the 5th module, that is feedback and operational amplifier. In the last class, we have started on feedback amplifier. We discussed about positive and negative feedback and the basic concepts and principle of feedback amplifier. We have derived the expression of open loop gain and as well as closed loop gain for both positive and negative feedback. Now today we are going to start about types of amplifier and different types of feedback amplifiers. And the lesson objective of the today's discussions are: number 1 is the study the concept of both positive and negative feedback in electronic circuits. Study the different types of feedback amplifiers. And the today's topic is mapped with CO number 3. So let us start lecture number 2 from the 5th module, that is feedback and operational amplifier, with the topic of different types of feedback amplifier. So what are the different types of feedback amplifiers are present? So amplifiers can be broadly classified into the following 4 categories based on input and output impedances of the amplifier. These are voltage amplifier, current amplifier, transconductance amplifier, and transresistance amplifier. So all should be explained, all we are going to explain one by one. So first we start from voltage amplifier. Voltage amplifier, that means in the input we are applying a voltage. It is basically a two-port network. It consists of Thevenin's network both in the input and output stage. So voltage amplifier, that means in the input you are applying a voltage and from output we also get the voltage. So the RS resistance is in series in voltage source. Similarly, the output RO also in series. Output resistance RO is also in series with V0. So the source resistance is RS and the load resistance RL. Ri and R0 are the input and output impedances of the amplifier respectively. Now if Ri much greater than Rs, if Ri much greater than Rs and R0 much less than RL, then what will be the output voltage? The output voltage V0 is equal to AV into Vi, where Vi is the internal input voltage. So AV is the voltage gain of the amplifier. Hence, this circuit is called, or Vi is same as Vs equivalently. So AV into Vs we can say. So this circuit is called voltage amplifier circuit. And the open circuit voltage gain of an amplifier AV, which is denoted as AV, it is basically a ratio of V0 by Vi, where RL equal to say infinity. So this is voltage amplifier. Next is the current amplifier. Current amplifier, that means in input we are setting a current source, and from the output our desired output is current. So current source, that means resistance is in parallel, input resistance. Similarly, output resistance is also in parallel, and the current gain is denoted as AI. So the current amplifier is also a two-port network. It consists of Norton's network, both in the input and the output stage. The equivalent circuit of a current amplifier is shown here. Now, if Ri much less than Rs, if Ri much less than Rs and R0 much higher than RL, then the amplifier becomes a current amplifier with output current I0 equal to IL equal to AI into II. So II, which is almost same as IS. So where AI is called basically short circuit current gain of an amplifier. Short circuit current gain, why? Where say AI is equal to I0 by II when RL is 0. If RL is 0, in that case it is called the short circuit current gain. Okay. Next is the transconductance amplifier. Now, what is transconductance amplifier? Transconductance means current by voltage. So in the output we get current, and from input we are applying the voltage source. So voltage source, if we are applying voltage source at the input, then obviously RS in series connection and R0 is in parallel connection, because our intention is to get the output current. So the transconductance amplifier is a two-port network. It consists of Thevenin's network at the input stage and Norton's network in the output stage. Now, if Ri much higher than Rs and R0 much higher than RL, then the amplifier is called a transconductance amplifier, as it provides an output current which is proportional to the input voltage. That means IL equal to I0, which is same as Gm into Vi, or equivalently we can say that Gm into Vs, where Gm is called short circuit transconductance of an amplifier, which is denoted as a Gm equal to IL, or whatever, say I0 by Vi or I0 by Vs. Short circuit, that means whenever RL is 0. So Gm is denoted as I0 by, it is a ratio of I0 by Vs when for RL equal to 0. So this is transconductance amplifier. Next is the transresistance amplifier. Now, just the reverse of transconductance. That means in the input we are applying the current source, and from the output we get the voltage. So, transresistance amplifier is a two-port network. It consists of Norton's network at the input stage and Thevenin network in the output stage. So this is the transresistance amplifier. If Ri much less than Rs and R0 much less than RL, then the amplifier will provide an output voltage which is proportional to the input current. Such an amplifier is called transresistance amplifier, and the output voltage is given by V0 equal to Rm into II, which is Rm into Is, where Rm is called open circuit transresistance of an amplifier, which is denoted as Rm equal to V0 by Is. Open circuit, that means RL is infinity. So whenever RL is infinity, it is called open circuit transresistance. Okay. So these are the four possible combinations of feedback amplifier, or four categories of feedback amplifier based on their input output impedance. So amplifier can be divided into four groups, which is done on the basis of the quantity to be amplified. So maybe a voltage or current as the desired from the output. So a signal loop A single loop feedback connections around a basic amplifier is generally represented is like that. Here, Vi is the difference signal produced due to the combination of the input signal Vs and the feedback signal Vf. This is the input output characteristics of an amplifier with and without feedback. So this curve is, first curve is the without feedback, and second this curve is the with feedback input output characteristics. Now depending on the mixing, so what are the different types of mixing connection in feedback amplifier? So depending on the mixing of the input signal Vs and feedback signal Vf, two types of mixture circuits are possible. One is called series mixture and other is called shunt mixture. So first circuit, this is called series mixing. See here, this is the series mixture connection. Next is the another type of mixing. This, see, here is a series connection, and see, this is in parallel. That is the shunt type of mixture. In parallel connection, that is in current source is applied. Okay. Now, sampling. Two types of sampling network connections are present. One is called voltage sampling and other is called current sampling. First one is the voltage sampling and second one is the current sampling. So if the output voltage is sampled by connecting the feedback network in shunt across the output, then voltage sampling is occurred. In the first figure, see the output signal or output voltage is sampled. Just see the connecting the feedback network in parallel. So this is the voltage sampling. And if the output voltage is sampled by connecting the feedback network in series with the output, then the current sampling takes place. See in this figure. So here the feedback network is in series connection. So we get from here, current sampling can be occurred. So with the combination of series and shunt mixing at the input stage, and from the output stage, that is voltage sampling and current sampling, with the combination of four different possible sampling and mixing connection, we get total 4 types of topologies. So these topologies are basically voltage series feedback or voltage sampling series mixing. See, voltage series feedback, that means voltage sampling output signal feedback, voltage sampling series mixing, voltage sampling series mixing, voltage shunt feedback, voltage sampling shunt mixing, current series feedback, current sampling series mixing, current shunt feedback, current sampling shunt mixing. So these are the 4 possible combinations of feedback topologies are present depending on series connection and series shunt connection, combinations of series shunt connection, and the combination of sampling, voltage sampling or current sampling. So we will discuss the 4 topologies in detail in the next class. Okay. So thank you so much. Now I am ending the today's class.